Assalamualaikum everybody. This is Farhana Sultana Toma here, Faculty of Chemical and Process Engineering Technology, University Malaysia Pahang. I would like to talk about my paper which has been accepted in ICER's 2020 conference. My paper ID is 43. The title of my paper is Comparison between lignin extraction by alkaline and ultrasound-assisted alkaline treatment from oil palm empty fruit bunch. Introduction. First, I would like to introduce about lignocellulose. Lignocellulose is the most abundantly available raw material on the earth for the production of biofuels, mainly bioethanol. It is composed of carbohydrate polymers of holocellulose, which consists cellulose and hemicellulose, and another is an aromatic polymer, which is lignin. Next, lignin. Lignin is the second most prevalent biopolymer after cellulose. It is an amorphous, irregular, three-dimensional and highly branched phenolic polymer. Lignin is a class of complex organic polymers that form key structural materials in the support tissues of vascular plants and some algae. Lignin comprises 20 to 30% of biomass. It is composed by three phenyl propane monomers, which are coumaryl alcohol, coniferyl alcohol, and syringel alcohol. Applications of lignin. Lignin can be used in a wide range of applications ranging from fuels to advanced chemicals and materials. Lignin can be used as fine chemicals such as phenolic compounds, binders, adhesives, dispersants, paints, and so on. In addition to fuel production, the diverse applications of lignin can be found in chemical production, specialty materials, pulp and paper industries, pharmaceuticals, and environmental purposes. Due to the versatile properties of lignin, various value-added industrial applications have been recognized. Problem statement. The problem statement of my work is, it is very difficult to select the delignification process for lignin extraction from fiber. Delignification process can be tedious and the success can be discouraging. So, selection of feedstock and selection of pretreatment method is very important to extraction of lignin. Objective. To study the objective is to isolate lignin from oil palm empty fruit bunch using alkaline and ultrasound-assisted alkaline methods. To study the effect of alkali concentration, temperature, extraction time, and sonication time. To compare the delignification ability of the two different methods. Oil palm empty fruit bunch is used as raw material and sodium hydroxide is used as an alkali. Temperature, time, and concentration of alkali solvent are parameters taken as manipulated variables. Characterization of lignin by FTIR, UV-vis, TGA, elemental analysis, and comparison between two different methods of lignin extraction. Pretreatment of lignin. This is an out-of-bore pretreatment of lignin. In pretreatment process, fiber treated with alkali and after that separated from cellulose and hemicellulose. Methodology. Lignin extraction by alkali method. This is the first method of my work. So and it is the procedure to extract lignin by alkali method. And the second methodology is lignin extraction by ultrasound-assisted alkaline method, and it is the procedure of ultrasound-assisted alkaline method. Resultant discussion. Effect of time. First effect of time on alkali and ultrasound-assisted alkali lignin extraction. Figure shows that the extension of treatment time tends to favor the lignin extraction yield. And this is the proof. UV-vis of extracted lignin using two different methods. UV spectroscopy analysis has been used to semi-quantitatively define the purity of lignin. Ultrasound-assisted alkali method has higher absorbance compared to alkali lignin. FTIR of lignin. The spectrum clearly has shown the presence of various functional groups such as hydrogen bonded, carbonyl stressing, unconjugated ketone, and carbonyl group. It also shown the skeleton vibrations due to glycine group, aromatic carbon hydrogen in plane deformation, and aromatic carbon hydrogen out of the plane deformation. The FTIR peak with and without ultrasound extraction was not so much different. The sonochemical vibration did not affect the structure of alkali lignin from oil palm empty fruit bunch. TGA. The thermal stability of the isolated lignin compound was studied by measuring the weight loss percentages concerning temperature using thermogravimetric analyzer. From the figure it showed that thermal stability is higher in ultrasound-assisted alkaline extracted lignin than in the alkaline extracted lignin. Conclusion. Ultrasound-assisted method has the ability of cracking cell walls and cause fibrillation by giving more exposure, which gives reasonable good result of delignification. Despite of a similar chemical composition, ultrasound-assisted lignin is more pure and percentages greater than alkali lignin. In ultrasound-assisted alkaline method, the percentage of lignin is 21.5, whereas lignin in alkali extraction process is 19.8. The thermal stability of ultrasound-assisted alkali lignin is higher than alkali lignin. Last of all, I would like to thank the organizer of ISITE's 2020 conference because they gave me the opportunity to share my work here. And thank you so much for your kind attention. That's all.